Now we're going to look at solving more types of quadratic systems. So in the past, you've learned how to solve systems of linear equations. That's when we have two lines and we're looking at where these two lines intersect. So you can either have one solution, you can have infinitely many solutions when they are actually the same line, or you can have no solution when they are parallel lines. We've also looked at what happens when I intersect a parabola with a line or a parabola with a parabola. So remember, again, I can still have two solutions, one solution, or no solution if they do not intersect. So now we're going to be looking at other types of quadratic systems. These systems can involve linear functions as well as our conic sections, so hyperbolas, ellipses, circles, parabolas, and we can have more than two solutions. So even in these examples here, you can see how we have three solutions. When solving a system of equations, you can use substitution, elimination, or graphing. Now, algebraically, substitution and elimination are the only methods we have. So when given this type of system here, we can choose to use substitution or elimination. For this particular system, either will work. So I'm going to use elimination. So lining these guys up, which they already are, I'm going to go ahead and subtract. So I'm going to make every term on the bottom negative. So now when I add down, I eliminate one of the terms. So you want to get rid of one of these squared terms or one of the variables. Now, if I had a linear system with a quadratic system, you probably want to use substitution. So now 64y squared minus 1y squared gives me 63y squared. 64 minus 64 is 0. So dividing by 63, I get y squared is 0. So y is just going to be 0. Now that we've gotten rid of one of the variables and I've solved for the other variable, so I've solved for y, we want to substitute this back into one of the original equations. Now it does not matter which one we substitute it back into, but I'm going to pick the easier one, which is this one. So I'm going to have x squared plus 0 squared equals 64. So x squared equals 64. So when I take the square root of each side, x is going to be positive and negative 8. Okay, so make sure you remember that plus minus. Alright, so I have x is these two values and y is this value. So I'm going to have two coordinates as my solution. X can be 8 and y can be 0. And x can be negative 8 when y is 0. So we're going to go ahead and check our answer. So you want to plug these answers back into the original equation to make sure that they work. So plugging in 8, I better get 0 for y. So I get 8 squared plus 64 y squared equals 64. So 64 plus 64 y squared equals 64. Subtracting those. 64 y squared equals 0. And when you divide out, you get y squared equals 0. So we know y will be 0. Now because we are squaring these, when I plug in negative 8 into the same function, I'm going to get the same thing. So let's go ahead and check the other equation, because remember you have to check both. So I'm going to check the other one. 8 squared plus y squared equals 64. Subtracting 64 from both sides. Y squared equals 0, so again y will be 0. So both times our solutions worked for both equations. You must check both. In order to solve a system graphically, you must first graph each relation separately and then see where they overlap or intersect, or if they don't intersect at all. So for this system, we are going to first put everything in standard form. So for this first function here, I need to divide everything by 64. So once we divide out by 64, we can see that we are going to be an ellipse. We're going to have our vertices on the x-axis, so we're going to be horizontally oriented. So our vertices are going to be at plus or minus 8, 0. And our co-vertices here on the y-axis are going to be 0, plus or minus 1. And we're going to be centered at 0, 0. Now for the second relation, you can see that we have no terms in front of the x squared and the y squared. So if I were to divide out by 64, I get x squared over 64 plus y squared over 64 equals 1. Now if I were to try to graph that, that's just going to be an ellipse with co-vertices and vertices at plus or minus 8, 0, and 0 plus or minus 8, which if you graph that just looks like a circle. So this is actually just a circle with center 0, 0, and my radius here is equal to 8, because remember this is always the r squared term. So now we're just going to graph each relation separately and then see where they overlap. So first I'm going to start with the ellipse. So we have vertices at positive and negative 8, 0. Our center is going to be 0, 0. And co-vertices at 0 plus or minus 1. Connecting those. Now drawing the circle, I have center 0, 0 again, and then I have a radius of 8. So we're going to go up 8, down 8, and left and right 8. Connecting those. So, as you can see, graphically we get the same solution we did before, which was negative 8, 0 and positive 8, 0. So if you were to plug these back into each of the relations, again, they would give you the correct solution. Alright guys, now give this one a try.